Of all the worlds in our solar system, and all the wonders uncovered by humanity's venture into the cosmic expanse, only one planet wears its seas in the open. Planet Earth, our water world. The ocean covers around 71% of Earth's surface. From above, this vastness presents itself as little more than a sheet of endless blue, vanishing over a far horizon. Somewhere in that blue, in the warm tropical waters off Indonesia in the Indo-West Pacific, a shape breaks the surface. An Omura whale. One of the smallest and most elusive of the great whales. And she is not alone. A calf, likely only a few months old, shelters in the slipstream beneath her body. Rising now and then to take a quick breath at the surface, before tucking back under her flank. For many months he will drink his mother's rich milk, putting on weight at extraordinary speed, learning how to be a whale among the shifting moods of the sea. In time, he will need to navigate this ocean on his own. But sightings like this are rare. And with very little known about this whale, details of where they go and how they live are a mystery. What little we've seen suggests they spend their lives in these warm shallows, rarely venturing into the colder, deeper deserts beyond. Even the giants from the great blue distances come here. At up to 30 meters long, with a tongue alone that weighs as much as an elephant, the blue whale is the largest animal ever known. To reach these waters, she has had to cross entire oceans, a journey that spans thousands of kilometers. She has come to a very particular place. At the intersection of the Pacific and Indian Oceans, the waters of two great systems mix to create a sanctuary of life. An Indo-Pacific paradise called the Coral Triangle. It spans some 5.7 million square kilometers and 6 nations. Indonesia, Malaysia, the Philippines, Timor-Leste, Papua New Guinea, and the Solomon Islands. Within this wedge of ocean lies the most biologically complex reef system on the planet. The reefs form an underwater web linking the innumerable islands that rise from the blue. From the air, they are scattered postcard worlds. Limestone peaks and forested atolls ringed with turquoise. Their fringes bloom into shallow water wonderlands of sand, seagrass, and coral. Nowhere are these worlds more abundant than the sprawling archipelago of Raja Ampat, at the very heart of the triangle. Here, the nutrient-laden waters of the Pacific thread their way between some 1,500 islands, funneled through narrow straits and deep channels, stirring the sea and carrying life with it. This current, known as the Indonesian through flow, is among the most important and powerful on the planet. and it has transformed the Coral Triangle into a prolific oceanic otherworld. In these seas alone, more than 1,600 species of reef fish have been recorded, along with all but one of the known turtle species, and at least 17 kinds of marine mammal. Although on this channel we usually follow the great descent into the deep, today we rise to a world no less strange. For the reefs of the Coral Triangle are fed by the deep. Far below these islands, cold, dark water creeps along the sea floor, rich with the nutrients of countless drifting lives that have sunk and broken down in the depths. Driven by the through flow, some of that deep water is forced upwards, welling into the light. Here, in the shallows, those invisible gifts from the darkness meet tropical sun and living rock. As tides rush and whirl between cliff and reef, mixing this deep-born water again and again, trapping larvae, scattering beings into every fold and corner. Life has reached one of its most spectacular expressions. A vast, intricate metropolis. A city of living rock with towers, alleyways, and crowded markets. Yet, all of it is built on a creature of almost absurd simplicity. The coral polyp. Physically, this is a very simple animal. Little more than a soft, translucent bag with a ring of tentacles and a hole in the middle. Being so simple, that one hole must do everything. It is mouth and anus, all in one. Each polyp is only a few millimeters across, seated in a tiny limestone cup of its own making. A bunker it can vanish into at the slightest hint of danger. It spends its life at this doorway. Tentacles spread, feeling the current, stinging and drawing in passing plankton. The polyps may be small, but side by side, thousands of these tiny, simple bodies bud and divide, stitching themselves together into a single living skin. Inside that skin, something strange is happening. Packed into the polyp's tissues are countless microscopic algae. The polyp offers these tiny plants a stable home and a constant trickle of fertilizer from its own waste. In return, the algae use that waste, together with carbon dioxide and water, to harness the energy of the sun and flood the polyps with sugar. Light from a distant star falls on clear tropical water, is caught by the algae, passed into the coral as sugar, and turned into tissue. And with that energy, into limestone. A great share of the energy that runs through the reef passes through this pact between two tiny partners. From the invisible powers of photons, water, and dissolved chemicals, they build mass, shape, color, They lay down antlers and tables, spirals and domes, folded labyrinths and fine honeycombs. This is happening across 600 species here, each with its own architecture. Together, they turn thin blue water into a solid three-dimensional world. In this complexity, the reef becomes a nursery, a shelter, a larder, a meeting place. It is a kind of mother, ever growing, ever reshaping herself, holding in her arms an entire biome. In the Coral Triangle, that mother is as vast and as generous as the ocean has ever allowed. She will be our anchor throughout this journey. And so too will her children. The reef is home to thousands of specialists. For many, their specialism is born of a need to blend in. Some are less successful than others. And some are masters of this craft. Just briefly, here's a quick word from our sponsor. Thank you to Opera for sponsoring Natural World Facts. Opera is my new secret weapon for exploring the ocean right from my desk. My problem is, I'm all over the place when it comes to research. But with this browser, I feel I'm at the helm of a submersible with all I need for a successful deep dive. Most importantly, a soundtrack. Music is my marine snow, my vital essence. It's essential for those long nights researching and script writing. You can control your music right from the player with 7 built-in streaming services. The music player can even be detached, so you can move it anywhere you want, both inside and outside the browser window. Opera's split-screen mode is invaluable. Drag tabs down for up to 4 windows on one screen. And if you're always drowning in tabs like I am, Tab Traces helps you find the last few you've been toggling between. Meanwhile, Tab Islands keeps everything neatly grouped by topic so your chondrichthyon and osteichthyon research never mixes. You can try out Opera for yourself by clicking the link in the description box. Now let's journey back to the reef and the tiny lives of that Gorgonian mother. This is a Pygmy Seahorse. No more than 2 centimeters tall, clinging by its tail to the branches of a single coral fan. These rather rotund individuals are pregnant. Like all seahorses, the males are the ones who carry the babies, deposited by females in a pouch on their belly. He will nurture the developing young until they will be released, fully formed, to find a coral of their own to inhabit. For this tiny animal, the Reef Mother narrows down to a single Gorgonian sea fan. Some Pygmy seahorses live their whole adult lives on just one of these corals, and go nowhere else. The fan is their whole universe. So reliant are they on their coral mother that they have become an almost perfect imitation. Their bodies are covered in bulbous, bony tubercles that rise from the skin in the exact positions of the coral's polyps. Their appearance mirrors the Gorgonian's surface so closely that, for decades, no one knew they were there at all. Despite living only 16 meters deep, they were not discovered until 1969. Their devotion has a cost. by tying their entire existence to one kind of coral. They gain perfect camouflage, but also vulnerability. If the fan sickens, they are unlikely to survive. For the Pygmy Seahorse, the Reef Mother is a single branch in a single corner of her body. For others, she is something far larger. Pull back, and the fan dissolves into a forest of corals, crafting ridges, gullies, and the vaulted halls of caves and overhangs. This is the reef as a labyrinth. A three-dimensional web of cracks, crevices, doorways, and dead ends. To some, this maze is a shelter. But of those hiding away, few are truly safe. For to others, this labyrinth is the sprawl of a most bountiful hunting ground. At night, the sea krait slips into the coral's inner spaces like a ribbon of muscle, probing the hidden recesses. The snake's jaws, small at the tip of its flexible, skinny body, are perfectly shaped to prize prey from tight spaces larger hunters would struggle to reach. And joining forces with others to comb the reef with deadly precision, working to drive fish from their hiding spots, sometimes in groups over 100 strong. By day, the hunt draws to an end, and sooner or later the krait must leave this world behind. For all its mastery of this underwater forest, the sea krait still carries the compromises of a land snake. It has lungs instead of gills, and a body not built for endless immersion. It can dive deep into the reef, but it must return to the surface to breathe. And uniquely among sea snakes, it must go ashore to digest its meal. It lives on a tide of its own, forever shuttling between elements, down into the blue to hunt. And when its belly is full, back to the islands of the archipelago. It's a way of life shared by many in this shifting threshold where land and sea collide. Across the coral triangle, the reef's influence spills onto the shore and into the lives of many who reside here. On Komodo's beaches far southwest of Raja Ampat, huge dragons patrolled the tide line, scavenging washed-up fish and turtles, and even swimming between islands in search of food. In the mangrove-fringed bays of Indonesia and the Philippines, long-tailed crab-eating macaques wade through the shallows, turning stones and probing roots for crabs and shellfish. Along the cliffs and outer islets, seabirds trace invisible highways between nesting ledges and feeding grounds offshore. And of course, there's us. For thousands of years, people have lived along these coasts, timing their days to the tides and living on the bounty of the blue. Children learn to swim almost as soon as they can walk. Soon after, they're out with parents and grandparents, diving with masks and simple spears or hand lines, taking just enough fish for the evening meal. More than 100 million people in the Triangle's coastal zones depend on these waters for food and livelihood. Hundreds of millions more feel their influence through trade. As populations grow and outside markets reach ever deeper into these waters, some reefs are being asked for more than they can give. And this bond is coming under strain. When the reef thrives, so too do the human lives that fringe it. Both are children of the same vast, intricate sea. The story of humanity here is intertwined with the evolution of the landscape through deep time. The seascape of the Coral Triangle was forged by a chaotic history. Its extraordinary diversity was driven by two great engines. First, the slow violence of plate tectonics broke the seafloor into a maze of deep trenches, volcanic arcs and shallow shelves, scattering islands across the tropics. Then, again and again, came the ice ages. Vast amounts of water became locked up in polar ice, causing sea levels to fall by more than 100 meters. Shallow seas were cut off from the open ocean, turned into semi-isolated basins and inland seas. Those watery pockets of trapped ocean became forges of speciation. Within, reef communities followed their own paths, and new species took on forms found nowhere else. Long after, when the ice melted and the seas rose again, the walls of these isolated pockets were flooded. This is the key moment where the Indonesian through-flow began to thread its way between them, flushing these uniquely evolved species out of their isolation and scattering them across the entire region. Some spread. Some met their close cousins again after hundreds of thousands of years apart, and hybridized. The Coral Triangle became a unique crossroads, where many alternate histories of the same ocean meet. This phenomenon is responsible for the unparalleled species richness found in these waters. This richness, in turn, can only persist because it encounters an environment of monumental physical complexity. That complexity is the living geometry of the reef itself. From above, it looks like one continuous band of pale green in a field of blue. Zoom closer, and that band breaks apart into headlands and lagoons, bommies and passes. Closer still, and each bommie becomes a city of corals, each coral a tower of branches and plates and folds. Keep going. A single branch reveals terraces and ledges and tiny overhangs. The surface of that branch is not smooth but scalloped with ridges and pits, each one creating shelter in its own shadow and changing how the water flows around it. Within those pits lie finer structures, films of bacteria, forests of microscopic algae, grains of sand cemented in place. At every level, from the shape of the whole reef down to the minute crenellations on a single coral, there is complexity. Seen this way, the reef is a pattern that repeats in endless variation. A fractal of wild, holding meaning and refuge at every scale. From the sweep of the archipelago to the smallest hollow. This living archive holds clues to our own ancestry. Hidden among its folds are creatures that carry echoes of where we ourselves come from. And that link is these clustered beads. They are called tunicates, sea squirts, and believe it or not, they are distant cousins to every backboned creature on Earth. Their life begins as a voyager, a free-swimming larva propelled by a tail and supported by a simple rod of tissue, a notochord, the ancestral blueprint from which the vertebrate backbone evolved. But its larval life is brief. Upon settling on the reef, it presses its head to the rock and undergoes a profound metamorphosis. It digests its own brain, absorbs its tail, and dissolves its notochord, destroying the very structures that made it mobile and aware, to become a static, soft-walled sac quietly pumping seawater and sieving out food. This dramatic metamorphosis is why adult tunicates don't exactly resemble us or any of our vertebrate kin. But their larval form reveals a deep evolutionary link. Just like us, they begin their life with a notochord. While theirs dissolves when they settle, we build a backbone around ours instead. The coral's complex structures create an unfathomable array of homes. But this comes with a cost. So many mouths, so many eyes packed into such a small space means the very conditions that foster such extraordinary diversity also create one of the most competitive environments on Earth. Every centimeter is contested. In a world this crowded, the best solutions tend to be the most creative. The labyrinth of islands, ridges, and coral offer countless backgrounds to blend into. Over millions of years, evolution has woven the specific texture of volcanic stone, the shade of a particular rock, and the precise colors of living coral into the very skin of its subjects. It turns animals into living fragments of the reef itself, moving pieces of rock, algae, and coral that the eye simply slides over. Eschmeyer's scorpionfish, Rhinopius, is one of many ambush predators that emerge from the shaping force of the reef's textures. Because Rhinopius moves so little, real algae and tiny parasites quickly begin to settle on its skin, just as they do on the surrounding rock. To clear them, it periodically sheds the outer layer of skin. On flatter portions of the reef, where rock and coral is sparse, it helps to keep a low profile. Lying motionless, with a flattened body casting no shadow, the crocodile fish is almost impossible to see. Frills, tassels, and ridges break up its outline. To complete the look, each dark eye is veiled by a lace-like fringe called a lappet, shattering the clear circle of the pupil into irregular shapes. A finishing touch, ensuring no aspect of its morphology gives it away. This allows it to become a patient, living trap, even when it moves. Skulking along the sea floor, moving its eyes independently of one another at the top of its very flat head, scanning a wide panoramic area Meanwhile, the ghost pipefish has altered its body to such an extent that it hardly resembles a fish at all. In fact, they hardly resemble each other. This one, the robust ghost pipefish, has made its home on the seagrass beds, lost among the leafy blades. This ornate ghost pipefish redraws that blueprint with a spray of spines and filigree. Each little fringe is a modified fin ray or flap of skin that echoes the branching polyps of the coral it drifts beside. It even goes so far as to angle itself to match the direction of growth of the coral structure. Its colors are no accident either. As a transparent larva, it lives out in the open water, and only when it settles on the reef does it begin to take on pigment to match its chosen host. Here, the same species has tuned to a different partner. Among the arms of a feather star, its fins and skin frills mimic the crinoid's own feathery branches. But in the pursuit of perfect camouflage, the fish of the reef haven't stopped there. This beauty is what happens when a fish gives up on appearing graceful. No sleek torpedo here. No forked tail for speed. Just a semi-amorphous lump. But on reefs like this, form follows genius rather than beauty. And that lump is a true masterpiece of adaptation. The frogfish, with its short, globular, unapologetically unstreamlined body, is expertly camouflaged to resemble sponges or algae-covered rocks. Even their fins have been repurposed. The pectoral and pelvic fins are set on little stalks, jointed like elbows, so that the frogfish can walk or gallop across the sea floor in a series of awkward lurching steps. These strange limbs let it anchor itself securely in place, essential for a predator that may need to remain motionless for hours. As a shallow water cousin of the deep-sea anglerfish, it shares their reputation as the dumpy, clumsy monster of its world. Yet for all its apparent awkwardness, there's nothing clumsy about it. Every bump is an upgrade for life as the ultimate ambush predator, perfected for one perfect, explosive moment of attack. Its most iconic feature, though, is a masterpiece of aggressive mimicry. The first dorsal spine has been transformed into a fishing rod and bait, the Elysium and Esker, just as we find in the anglerfish of the deep. The difference is, in these sun-drenched waters, there's no need to waste energy on bioluminescence. Their lure needs only resemble something fleshy and wriggling. Across the family, these lures take on astonishing forms. Some trail thick, worm-like tendrils. Others mimic a tiny fish, complete with spots where the eyes should be. Still others dangle a tuft that looks uncannily like a small shrimp or drifting crustacean. This elaborate performance, the stillness, the camouflage, the tantalizing lure, all culminate in a single explosive moment. When prey is drawn into the kill zone, the frogfish executes one of the fastest predatory strikes of any vertebrate on Earth. In as little as 6 milliseconds, a blur too fast for the victim's nervous system to even register. It sucks the prey into its mouth, along with the surrounding water. But this strategy relies on an environment that provides places to hide. Not all areas of the Coral Triangle offer such a luxury. Venture out beyond the shelter of the reef. Beyond even the fringes where the crocodile fish blend among the rubble. And we enter a far more hostile world. The sandy bottom. These places are born from the sheddings of the reef. All the decomposing material, the droppings, castings, coral fragments, and other sediment, created by the hustle and bustle of that crowded world, are swept from the reef by the strong currents and deposited here in calmer, deeper areas and channels, forming expansive sandy flats at the edge of the place where the great blue void presses in. These vast exposed sea floors present a different sort of problem. There are no rocks in which to hide away, no corals to impersonate. Living out here hinges on being more inventive. Garden eels. In this exposed world, they've managed to cultivate something far more significant than any coral or rock crevice. Community. Living in large colonies like this provides safety by creating a sort of neighborhood watch. With so many eyes eternally scanning the outer sands, a looming predator will struggle to go unnoticed. Loom too near, and the burrows offer hiding spots and shelter for smaller marine animals, such as various species of shrimp and crab, protecting them from predators in the open flats. While the eels survive by forging their own ecosystem, the true masters of this place survive by forging a new reality, the power to shapeshift, a power that has been perfected by the octopus. It can transform its entire skin in as little as 200 milliseconds, faster than the blink of a human eye, allowing it to dance from sand to rock to coral with ease while remaining stealthy. Such a feat would be impossible with a centralized brain like ours. The processing load would be overwhelming. Instead, the octopus utilizes a decentralized nervous system. While its brain makes the strategic decision to hide, the bulk of the work is offloaded to roughly 350 million neurons spread throughout its arms. These arms function as parallel processors, each analyzing the local environment and executing the complex changes in pattern and texture across sections of the skin. Neurally controlled muscles instantly expand or contract chromatophores. Tiny sacs containing yellow, red, brown, or black pigment. Underneath, a layer of reflective cells manipulates light. Cells called iridophores produce iridescent and metallic sheens of blue and green, while lucifores scatter ambient light to perfectly match the surrounding brightness. Finally, to complete the illusion, muscular bundles called papillae can be raised or retracted, altering the skin's physical structure to mimic the three-dimensional texture of any surface. From smooth sand to complex coral. In its most advanced form, active camouflage moves beyond simply matching a background, and it becomes a tool for proactive, tactical behavior. Even with their power to shapeshift, for a soft-bodied octopus on the open seabed, every piece of cover is valuable. Most octopuses make do with empty bivalve shells, but the discarded halves of a coconut are a rare find. Light, tough, perfectly curved, and portable. A suit of armor that can be carried from place to place. The problem is getting them there. With its arms wrapped awkwardly around the shells, the octopus must totter across the open sand. But the risk is worth it. The two halves close around it like armor, and the spherical perfection of the coconut creates an escape capsule, rolling down the sandy hill. This little deceiver is the Mimic Octopus, a name it has earned through its proclivity for identity theft. Rather than just hiding, it observes and studies its neighbors, watching for those that seem to be avoided by predators. And then, they use their toolbox of special cells and flexible arms to put on a show. Observers have documented this octopus performing a wide repertoire of impersonations. For instance, when traveling, it can flatten its body and arms, propelling itself along the seafloor in a perfect imitation of a flounder. You know what they say? Imitation is the sincerest form of flattery. On the reef, it is also a way to stay alive. Most creatures here follow the path of disappearance, blending into sand, stone, and coral to escape notice. But the reef is also home to another rival power. A trickster current in evolution. Don't hide. Stand out. And advertise yourself as a deadly meal. It's a bold decision, but this flamboyant cuttlefish goes against the grain of its shy octopus cousins. It shows off. On the sand, it pulses with rolling bands of color racing down its body. To a predator, this is a warning. This species is thought to be the only truly toxic cuttlefish yet discovered. In its flesh, scientists have found a powerful toxin, similar to the one that makes pufferfish and blue-ringed octopus so dangerous. It's called tetrodotoxin, a compound that blocks nerve signals, leading to paralysis and, if enough is taken, respiratory failure. Armed with such chemistry, the cuttlefish can afford to be conspicuous, so long as everyone knows what those colors mean. That is the essence of aposematism. Bright, unmistakable patterns that say, yes, you can catch me, but you'll regret it. The behavior of this cuttlefish serves a double purpose. Recent studies have revealed these backward-moving pulses may serve to disorient their prey, The moving stripes break up the cuttlefish's outline and create a shifting background of light and dark, making it hard for a fish or shrimp to judge exactly where the danger begins or how fast it's closing in. This strategy of advertising danger proliferates across the reef. Lionfish, close relatives of the rhinopious scorpionfish we saw earlier, wear bold warning bands where their cousins rely on camouflage. Their long fins flare like a mane, framing rows of rigid venomous spines along their back and belly. One careless bite into their flesh can deliver a powerful neurotoxin into the mouth of a predator. The message is clear enough that most local hunters leave them well alone. And it has worked so well that, with human help, lionfish have spread far beyond their native Indo-Pacific home, invading reefs on the other side of the world. Nowhere is the art of aposematism more perfected than the Coral Triangle. These are the nudibranchs, sea slugs whose distant ancestors once crept about in heavy shells, much like ordinary snails. Long ago, they made a daring trade. They gave up that armor, left themselves soft and exposed in order to specialize in being inedible. Freed from the old constraint of carrying a shell, nudibranchs could explore new foods, new shapes, new ways of life. Biologists call this the escape and radiate idea. Escape your enemies with a new defense, and you're free to radiate into many new forms. Time and again, the nudibranchs have done just that. But their reef-wide reputation as untouchable, as things not to mess with, is built on a bit of a trick. Most nudibranchs are not born poisonous at all. Instead of evolving defenses from scratch, they steal their weapons. Many feed on toxic sponges and other chemically defended prey. As they eat, they do something remarkable. Instead of simply digesting these poisons, they filter out the most potent compounds and store them in special glands within their own tissues. The sponge's defense becomes the slug's shield. Others take an even bolder shortcut. They steal physical weapons. Certain nudibranchs feed on cnidarians such as jellyfish, hydroids, and anemones, whose tentacles are armed with microscopic stinging cells called nematocysts. Think of them as tiny harpoons primed to fire. The slugs can swallow these cells without triggering them, performing a careful robbery without setting off the alarms. The intact stinging cells are then moved into finger-like projections on their backs, the serrata. There, they are wired into the nudibranch's own body, ready to be used in its defense. Across the Coral Triangle, the diversity of nudibranchs we see today carries the imprint of deep time. Those isolated seas during the ice ages saw, in each pocket of water, nudibranchs facing a slightly different menu of toxic sponges, bryozoans, and cnidarians. Each local cuisine pushed them along a different evolutionary path of different chemicals, different warning colors. Then, as the ice melted and the seas rose. These once separate seas rejoined, and their nudibranchs met again. Isolation, adaptation, and reunion played out over and over across thousands of islands, turning a single lineage of shellless snails into a spectacular spectrum of forms. While the nudibranchs won their freedom by shedding armor, another clan on the reef chose the opposite path. They doubled down on the fortress. Their solution has been so successful that it has exploded into more than 7,000 species around the world. These are the crabs. Animals with a body plan so effective that evolution has reinvented it, independently, at least 5 separate times in a process biologists call carcinization, becoming crab-shaped. Their story begins with a trade. The ancestral lobster-like forms of many crabs relied on a powerful escape maneuver. A sudden backward flick of the tail that could launch it away from danger in an instant. The crabs gave that up. They reduced the long, vulnerable abdomen, flattened it, and folded it permanently beneath the body, tucking it safely under a broad, heavily armored shell. Inside that shield lie the vital organs, and in females, the developing eggs. This new bow plan or body plan is a masterpiece of physical defense. The compact, flattened body is perfectly suited to vanishing into cracks in rocks and coral, wedging tight where larger predators cannot follow. The low center of gravity, spread out over 4 pairs of strong legs, is ideal for rapid sideways scuttling. A darting, unpredictable movement that makes nonsense of a predator's straightforward attack. The armor itself is a formidable shield. Similar to case-hardened steel, it features a hard outer exocuticle to resist penetration and a tougher inner endocuticle to absorb energy, engineered to withstand the crushing and piercing forces of a predator, which frees some of them to do this. This is a Pom Pom Crab. Barely the size of a fingernail, it strides across the reef like a tiny cheerleader. Claws raised, waving anemones plucked from the reef as living pom-poms, for both defense and as a hunting tool. And then there's the Decorator Crab. Where other crabs put their energy into thicker armor and bigger claws, this one has gone all in on wardrobe. Its shell bristles with tiny hooked hairs like Velcro. Onto this, it carefully fastens bits of sponge and seaweed, and whole gardens of hydroids, until the crab all but vanishes under its own outfit. For the hydroids, hitching a lift on a moving crab brings them into new currents and better feeding opportunities than their rock-bound relatives enjoy. It seems it helps to be artistic, even if some get a little abstract. All the intense competition of the reef forces life down ever more specialized, divergent paths. This pressure has forged a world of solitary masters. Masters of ambush, of chemical warfare, and deception. But in an ecosystem so defined by this arms race, one of the most powerful evolutionary forces is to abandon the conflict altogether and cooperate. This is the concept of mutualism, where two completely different species collaborate for a shared goal: to survive. On the sea floor, a near-blind shrimp meticulously excavates a burrow, a home it shares with a sharp-eyed goby, which stands guard, paying for its rent with vigilance. Meanwhile, at bustling cleaning stations, small cleaner wrasse trade their hygienic services, removing parasites from clients like spadefish for a reliable meal. A truce of mutual benefit. But no symbiotic partnership is more iconic than that between the clownfish and the sea anemone. Survival is achieved through sophisticated molecular mimicry. The clownfish's immunity to the anemone's stings is not due to a physical shield, but a chemical one. The clownfish modulates the level of sialic acids in its mucus layer, those being the specific sugar molecules that trigger the stinging cells of the anemone. By changing its chemical signature, the fish becomes immunologically invisible, a functional part of the host's own tissue. So it's not so much that the anemone takes kindly to the fish. It's through deception, again, that the clownfish endures. But the anemone had no reason to evolve a way of overcoming this deception. It, too, benefits from the relationship. Through its territorial behavior, the clownfish provides active defense against corallivores who would seek to nibble at the anemone, such as butterfly fish, and performs hygienic services by removing parasites. But the greatest gift the fish bestow upon their host is their poo. The fish's nitrogenous waste directly fertilizes the anemone's endosymbiotic algae, a vital resource transfer in these nutrient-poor waters of the coral reef. As for the clownfish, it gains a permanent defended territory in an intensely competitive environment. While alliances between different species represent a remarkable evolutionary tactic, a far more fundamental and widespread strategy is cooperation within a species. The most unexpectedly spectacular example of this is the school of fish. This is not merely a group, but a superorganism. A single coordinated entity, where the group's behavior transcends the capabilities of its individual parts. Here, thousands of fish move as one, gaining defensive advantages unavailable to any solitary animal. This strategy relies on several key principles. The first is the dilution effect, where the statistical chance of any one fish being captured is dramatically reduced. Second is the predator confusion effect, where the shimmering, swirling mass of bodies overloads a hunter's visual processing. This makes it almost impossible to isolate and track a single target. Try it now. See if you can follow a single fish with your eyes without getting lost in the swarm. Finally, the many eyes of the schooling fish creates a near impenetrable sphere of collective vigilance, allowing the group to detect and react to threats with incredible speed. But the true driving force of these immense shoals is the power of the Indonesian through flow, as it brings up immense quantities of nutrients from the deep, feeding the phytoplankton that fuel the entire food web. And with it, all the uncounted ways creatures find to survive in the face of constant danger. Some have slipped those rules. From the blue beyond come wandering giants. Graceful and unhurried, they have no need of poison, armor, or camouflage. They live at a scale where most dangers fall away. These are the guardians. Some have traveled thousands of miles to visit the Reef Mother. The reef is built on a current of energy. The tiny plants in the sunlit water catch the light and turn it into sugar. Zooplankton feed on them, small fish feed on the zooplankton, and bigger hunters feed on the fish. At each step, most of that energy is lost as heat, movement, and waste. By the time it reaches the predators at the top of the food chain, only a thin trickle is left. The Guardians have transcended this chain. They have abandoned the complicated middle steps of the food web, harvesting the energy they need directly from the clouds of plankton that drift with the currents. By keeping their food chain short, they can grow enormous. With the largest brain-to-body ratio of any fish, the Manta Ray glides over the reef. Raja Ampat is one of the few places on Earth where reef mantas and their larger oceanic cousins gather side by side. For the Reef Mother provides far more than food. Here, mantas visit cleaning stations where small fishes pick parasites from their skin. And in places like Wayag Lagoon, juveniles return again and again to a sheltered nursery of bays and channels. The mantas even feed the reef. By tracing the chemistry in their tissues, scientists have found that much of what they eat, about 2/3 or more, does not come from the reef, but from zooplankton that rise at night from the deep. The mantas undertake vertical voyages, diving down into those dim scattering layers to feed, then gliding back to the shallows to rest, be clean, and give birth. With each journey, they carry nutrients from depth towards the light, releasing them in the surface waters of coral that depend on a steady, unseen flow of nourishment from beyond the reef's edge. Another guardian at home in these seas is the largest fish in the world, the whale shark. Even as juveniles, they are vast, slow-swimming filter feeders the size of small buses. In places like Cenderawasih Bay, many seem to linger year-round. Here, traditional fishing platforms release clouds of bait fish and eggs into the water, and the whale sharks have learned to take advantage of this constant feast. The gatherings are overwhelmingly made up of young males, a kind of bachelor's quarter, where the next generation can feed and grow in relative safety, before taking on the long, hazardous journeys of adult life in the open ocean. Even the whale shark is dwarfed by another visitor. From feeding grounds thousands of miles away, blue whales sometimes pass through the Coral Triangle. The largest animals that have ever lived on Earth. They undertake a 5,000-kilometre migration from their Australian feeding grounds to the warm, sheltered calving grounds of the Banda Sea. As they dive deep to feed and surface to breathe, they enact a powerful transfer of nutrients known as the whale pump. They release vast, buoyant plumes of iron and nitrogen-rich waste into the sunlit water above, fertilizing the phytoplankton and supercharging the very base of the entire food web. They are the ecosystem's keystone stabilizers, the biological filters and nutrient pumps that connect the productivity of the deep sea and distant poles to the coastal reefs. They are engineers, maintaining the foundations of the entire Coral Triangle. For all they do while they live, their greatest gift to the reef is given only once, when their great bodies at last return to the water that raised them. Gases produced by bacteria within the decomposing body gets trapped by the blubber and causes the dead whale to float for a time. Tiger sharks are the first to answer, drawn by a plume of scent that may have traveled for miles. They begin to carve great mouthfuls of skin and blubber. What was, moments ago, one animal becomes many. Fuel for sharks and jacks and smaller scavengers that dart between the larger mouths to take their share. A whale this size can carry tens of tons of carbon and tissue. Enough food to nourish thousands of creatures, and to flood this stretch of sea with nutrients that will, in time, wash back over the reef. As the feast continues, the body will let out its gases and begin to fall, slowly, into darker water. In the end, what is not consumed here will drift down beyond the reach of the coral's light, coming to rest on the deep seabed. In the cold and quiet, the carcass will fuel a second bloom of life for 50 years or more. As the sun sets on this guardian's life, so too it sets on the reef. And another shift in the great cycle begins. One that occurs each night. In the darkening waters, a host of strangers emerge. Polyps extend their tentacles into the night. Feather stars uncurl. Brittle stars, worms, and hunting crabs pour from their hiding places. The Reef Mother does not sleep. She only turns her face and becomes a forest of tendrils and arms. A world ruled by touch, taste, and faint chemical trails. To truly know this reef, we must follow it now into the dark. Just want to take a moment to talk about an incredible resource made by this film's cinematographer. This is not a paid advert, this is just something he's made that is brilliant and is directly tied into the region, species, and much of the footage that you've just seen. A lot of the amazing footage in this film, from the mesmeric shoals to giant whales and tiny macro oddities, were filmed by one person, Eddie Frommenweiler, a camera operator based out in Indonesia. Eddie has spent decades filming underwater, and now he's turned all that footage into something called the Grand Blue Project. Essentially, it's a massive digital oceanopedia. It's full of information about over 1,400 species of the weird and wonderful creatures of the ocean. Every species gets its own page, 4K video, where it lives, how it behaves, what it eats, and how endangered it is. There's an interactive tree of life, my favourite part, showing how species are related, and if you're a diver, you can log your own sightings straight onto the map. So it can function a little bit like an ID book, a bit like iNaturalist, and as a fantastic educational resource if you're a student studying marine biology, or someone who's just generally interested in finding out more about ocean life. I truly would have given anything to have a resource like this, such a visual resource, when I was growing up and falling in love with the ocean. But at least I had endless ocean and Blue Planet to keep me going. But please do check this out. Once again, it's called the Grand Blue Project. Check it out in the description below.